Welcome and good day, guys. In this video we're going to proceed with the next subtopic in vector, which is direction angles and direction cosines. In other words, in this subtopic we're going to just figuring out what will be the angle of your vector, right? Previously we have already calculate the vector itself. Now we are going to try to find out the angle from the axis, the available axis. For two-dimensional it will be from x and y. For three-dimensional it will be from x, y and z. Okay, so if you look at this, right, let's try to look at the concept first. So to find the angle from x, right, to find the angle of p here as a vector from x, right, we try to find the alpha. Right, to find from the angle from y means that we're going to find it on beta, and as for z we're going to find the gamma. Okay, so the way to find the direction angle and direction cosine, right, basically just the direction angle, but we need to use later a cosine to find the angle. Okay, if you are clear about on how to find the angle in chapter 1, this will be easy for you to understand, right? It goes back to the idea of so, ka, and toa in trigonometry, right? Previously, if you can remember, in chapter 1 we used tangent to find the angle. Why? Because we have the information of opposite and adjacent. Okay, as for this one, if you look at this graph, if you have one vector, what will be the available information that you can obtain from it? Okay, so just imagine that you have a vector here. Okay, in trigonometry there will be three things that you need to look up for, whether it is the opposite, the adjacent, or the hypotenuse. So the opposite is, you know, the information opposite from the angle. The adjacent is the information obtained adjacent to the angle, and for the hypotenuse is the information obtained, you know, as the length obtained from opposite and adjacent. Okay, so let's look at this graph and determine what kind of information that we can have here. So do we have, if we were to find the angle, let's just look for maybe x here. If we want to find the angle here, what is the information that we can have from this? Assuming that we have this vector p, we can of course calculate for the length of this p, which will later represent the hypotenuse. So yes, we have hypotenuse. So out of these three, right, the possibility is to use either sin or cos. For tangent, right, not cos. Let's try to look everything. So we have hypotenuse, and then can we look for the information opposite of the angle, which is this one, right? We can't really get it, right? We don't have the information, so opposite, right, is not available. So the only things that we have now is ka, which is cosine adjacent over hypotenuse. So adjacent, do we have adjacent? So basically we can have adjacent, right, which is the information that we obtain from x here. So basically, if you want to find the angle of alpha, which is from x, yes, we have the adjacent, which is the x-axis. For y, the adjacent is the y-axis, and for z, the adjacent is the z-axis. So that's why we will use cosine here as the formula to find the angle. So if the question asks you to find the cosine, the direction cosine, basically they want you to find the cos. Let's say for x, which is cos alpha, equal to the value of adjacent, right, which is for this one the x, right, the x over the value of hypotenuse, which is for this one is the length of P, right? The same if you want to find the direction angle for beta, you are going to use the information of y as the adjacent, and for gamma you are going to use the information of z as the adjacent. Next, if they want you to find the direction angle, simply move the cosine at left hand side to the right hand side, so it will become cos inverse. So you just calculate cos inverse x over the hypotenuse to get the angle, right? Let's try. We try to do the example 3.5 if I'm not mistaken, but let us try to discuss a bit more on the concept. Okay, look at this. This is just like what we discussed just now, which is the direction cosine, and later when you calculate for the angle, right, the value of alpha, beta and gamma should be within this range, which is from 0 to 180. Okay, let's see why is it like that. Okay, so remember, the alpha, the beta and the gamma is the angle of each of these positive axes, where we have x, y and z positive from the vector. So positive and positive only. If let's say you have y in a negative value, let's say you have the p value of y the vector of that contain negative y, so it is in the negative area for y. In finding the angle, you should find the angle from the positive side, so we can expect it to be past 90 degree. Or let's just try to look from the x. Maybe it will be a little bit easier for us to see. So x, the negative x is at this area. Just imagine if your vector contain negative x value, so it should be the vector should be around here. So when calculating for your degree for x or alpha, you should calculate it. It should be measured from the positive x, not from the negative x. So we can expect that whenever you have a negative value of either x, y or z, your degree for each of them will be more than 90 degree, right? So for x here, if your x is positive, no problem, your degree will be within 90 degree here. But if it is if the vector is having a negative x, your degree later should be more than 90 degree, because you should measure from the positive axis to the negative. So you should have more than 90 degree. Let's try to do the example. Okay, let's look at exercise 3.5 and let's try to do this. We have we have a 2-dimensional and 3-dimensional cases. Okay, let me try. Let me input everything first. Okay, let us look at the first question. I minus Z3j. So if you try to put it in this form, it will be like this. I have calculated for the length, which is 2, and this is how to find out the direction cosine, which is cos alpha equal to the value of x, which is 1, and the value of the hypotenuse, which is 2. Okay, as for direction cosine for y, which is beta, negative Z3, which is the y, over 2 the hypotenuse. Now for this one we don't need to calculate it, because we don't have it, it is two-dimensional. If they ask you the question, just put 0 there, right? So to find out the angle for alpha here, right, we just put the cosine at the right hand side and you get 60 degree, and for this one you get 150 degree. Now let's try to make sense of it using a graphic. Okay, so this is how the graph should look like. 1, negative 3. Now to find the angle of x, right, we have the positive x, so no problem. To find the angle, we just find this angle from the positive x. So the value we get just now is 60, right? 60 degree. Okay, as for y, we get 150. Let's try to make sense of it. Remember that I said just now, to find the angle, it should be from the positive side. So our y now is negative 3, which is here, negative side. Okay, so to find the angle, we can't find it from this point, from the negative axis here. We should find from the positive axis, which is the positive y. So the 150 degree that you obtain from this calculation graphically is actually from y positive. So from y positive to the vector, this is 150. Okay, so that's what I said just now. When you calculate the angle, it should always be from positive. So we can expect that if your x positive, the angle should be less than 90 degree. If your x is negative, the angle should of course be more than 90 degree. More than 90 degree, right? Like this. If the same goes for y just now. If the y is positive, then when you calculate look for the degree, of course it will be less than 90 degree, because it will be just around this area. Now for this case, the y is negative. You still need to look for the angle from the positive side. Of course it will be more than 90 degree. The same goes for z. Later, when you have the z positive, you will get an angle less than 90 degree. If it is a negative value, you will get the angle that is more than 90 degree. But however, all of them should be less than 180 degree, just like what being shown here, right? So that is how to find the direction angle and direction cosine. Okay, thank you.